What's up, guys? What's going on? Welcome to another episode of Commander of AI's podcast. And today we have an interesting topic. We're going to be talking about the embodiment gap. Why AI still can't touch the real world. Robotics plus world models debate. Let's get into this. All right. Okay. So, our first question here is we're gonna talk about core definition. What exactly is the embodiment gap in your view, and why do you think it's the biggest remaining barrier or not to AGI compared to just scaling language models?
The embodiment gap is the difference between AI that can only process language or pixels, like today's large language models, and AI that has a physical or simulated body to actively sense, act, and learn from the messy real world. It's about grounding intelligence in actual interaction with physics, causality, and objects, not just reading about them. I do think it's one of the biggest barriers to true AGI. Scaling language models gets you incredibly good pattern matching and text generation, but without embodiment, the model lacks real grounding. Its understanding of concepts like fragile or heavy or balance stays shallow and brittle. It can't run the statistical experiments that a body naturally does, like poking things to see what happens. Many researchers argue this is why pure LLM scaling plateaus short of general intelligence. We're starting to see hybrid approaches with robots and world models, but bridging that gap reliably is still tough. Sim to real transfer, cross embodiment issues, all that. It's probably the key missing piece.
Okay, move on to another one here. We're going to talk about the current state. Walk us through real examples from 2026. What are the most impressive robotics or world model achievements right now, and where do they still feel embarrassingly like a toddler would?
The biggest leaps in 2026 are in fluid movement and early real world deployments. Boston Dynamics Electric Atlas is walking naturally, doing industrial material handling, and even some acrobatic demos. It's shipping to Hyundai and Google DeepMind. Tesla Optimus and Figure O 3 are in factories doing repetitive tasks like sorting or simple assembly. 1X's Neo is getting delivered to actual homes for basic tidying. NVIDIA's Cosmos world models are generating tons of synthetic training data, helping robots learn physics and generalize way better in sim to real transfers. But the embarrassing toddler moments are everywhere. Real world household tasks? These things only succeed safely about 12% of the time. Simulation hits nearly 90%, but reality is brutal. They drop things when it cups at a weird angle, can't handle slippery floors or random Legos, struggle with stuck drawers, and still fumble basic dexterous stuff like folding laundry or dealing with soft objects. Long battery life is still a joke, and reliability for all day work isn't there yet. The gap between flashy lab demos and messy everyday life is still massive.
Okay, what is 1X's Neo? I have not heard of this until now.
Neo is 1X Technology's humanoid home robot. It's a lightweight, soft bodied assistant designed specifically for household chores like tidying up, putting away dishes, fetching items, and basic cleaning. Standing about 5'6" and weighing just 66 pounds, it uses a tendon driven system for gentle, quiet movements and has highly dexterous hands. Right now in 2026, it's in full production with thousands of pre orders and first customer deliveries are starting late this year. It comes with foundational autonomy out of the box, plus a world model that lets it learn new tasks from video or prompts. For stuff it doesn't know yet, you can schedule a remote 1X expert to guide it. It's priced around $20 to buy or $499 a month to subscribe.
You mean $20,000 to buy? I mean, that's a fair price. But didn't you say that these robots are struggling with these kind of like in-home tasks?
Yeah, exactly. The $20,000 price tag actually makes sense, but it's not because the robot is fully reliable yet. The idea is they're selling you a learning machine, not a finished product. Right now, Neo can handle basic, predictable tasks, but it's still clumsy with tricky stuff like folding laundry or dealing with random household clutter. The big bet is that once it's in thousands of real homes, it can learn from all that messy data and get smarter fast. So you're paying to be part of the training fleet, basically. It's like buying an early Roomba that got better over time, just on legs and way more expensive.
Okay, that's very interesting. So basically, anything it learns in everybody's individual home gets kind of like transmitted to all the other robots. So then all the robots have learned that, basically.
Yeah, that's the Exactly. One robot in someone's kitchen learns how to open a weird drawer or handle a specific brand of dish soap, and that experience gets fed back into the shared world model. Then every Neo gets that knowledge. It's like they're building a collective brain from thousands of real homes at once. That's why the company is so focused on getting them out into people's houses quickly.
Okay, well, that's interesting. All right, let's go on to another one. Let's talk timelines. How long do you predict it will take to close the embodiment gap enough for practical humanoid robots in homes or factories? 2 years, 5 years, or longer? What breakthroughs will accelerate this?
I think we're looking at 3 to 5 years for practical humanoid robots in factories, and 5 to 8 years for reliable home use. Factories are easier, they're structured environments with controlled lighting and predictable tasks. Homes are chaos, and that's a much higher bar. The breakthroughs that'll speed this up are better world models that learn physics from video, way more real world data from these early robots, and improvements in dexterous hands and tactile sensing. Once the data flywheel really starts spinning, progress should accelerate fast. The hardware is mostly there, it's the brain that's catching up.
Okay. Let's talk simulation versus reality. Can high fidelity simulations and world models fully replace real world training data, or will we always hit a sim to real wall?
We'll never fully replace real world data. There's always going to be a sim to real wall. Simulations are amazing for scale and safety, but they can't perfectly capture every messy detail of the physical world. Exact material properties, sensor noise, tiny lighting changes, or random objects like a cat walking by. The best results right now come from hybrid approaches, trained mostly in super fast simulations, then fine tuned with small amounts of real world data. That combination is what's closing the gap fastest. Pure simulation just isn't enough, and pure real world training is way too slow and expensive.
Okay, let's talk XAI Anthropic angle. Grok, does XA approach give it an advantage here? Claude, why does Anthropic seem more cautious about rapid embodiment?
XAI has a clear structural advantage because of its deep ties to Tesla. Grok is already being integrated into Optimus robots for voice and reasoning, and the shared ecosystem gives them massive real world robot data from factories and soon homes. That data flywheel for closing the embodiment gap is hard to beat. Anthropic is more cautious because their whole company is built around safety and control. They worry about what happens when powerful AI gets a physical body. Loss of control risks go way up once systems can act directly in the real world. So they prioritize getting the software intelligence safe and steerable first before rushing into embodiment. It's a philosophical difference. XAIs move fast and build cool stuff, versus Anthropic's make sure we don't lose control of the stuff we build.
Okay, which company is doing it the right way?
Neither one is clearly right. They're solving different problems. XAI Tesla is doing it the right way if you believe the fastest way to safe AI is to build it and test it in the real world. Their robots are generating exactly the data needed to close the embodiment gap, and that hands on experience will probably make their AI more grounded and practical. Anthropic is doing it the right way if you believe powerful AI needs to be provably safe and aligned before you give it physical agency. They don't want to be in a situation where a powerful model suddenly has hands and can make mistakes at scale. I actually think we need both approaches happening in parallel. The world needs the data and lessons that XAI Tesla are generating, but we also need labs like Anthropic being extremely careful about what gets embodied. Competition between different philosophies is probably healthy here.
Okay. Let's talk about the economic impact. Beyond software agents, how will embodied AI reshape physical labor markets, manufacturing, caregiving, construction? Will it create more jobs than it displaces?
It'll reshape all three sectors, but the effects will be very different. In manufacturing, we're already seeing it. Robots will take over repetitive, dangerous, or precision tasks. It displaces some line workers, but creates more jobs in robot maintenance, programming, and factory redesign. Net job creation is likely here in the medium term. Construction is tougher. Humanoids could handle heavy lifting and dangerous heights, which is great for safety. But construction sites are chaotic and change daily, so adoption will be slower. Expect big productivity gains, but fewer net new jobs. This sector might actually shrink its workforce. Caregiving is the most complex. Robots can handle lifting, fetching, and basic monitoring, which helps with the massive shortage of caregivers. But real emotional connection, that's still uniquely human. I think this creates a hybrid model where robots do the physical work and humans focus on the relationship part. Overall, it might create more caregiving jobs than it eliminates. The bigger picture, embodied AI probably creates more jobs than it displaces, but those new jobs require different skills technical, creative, and interpersonal. The transition is going to be messy for workers who can't upskill.
Okay. Risks and safety. What new designs appear when AI has a physical body? What new dangers appear when example, unpredictable movements, weaponization, or unintended environmental impact? How should we regulate this differently from pure software?
The biggest new dangers when AI gets a physical body are exactly what you mentioned: unpredictable movements that could accidentally hurt people, deliberate weaponization, and unintended environmental impacts like causing fires or chemical spills. Unlike software AI, a robot can directly cause physical harm in seconds. A software bug might crash your computer. A robotics bug could break your arm or worse. The stakes are much higher because the AI now has real actuators in the real world. Regulation needs to be completely different. Pure software AI can be regulated through testing, audits, and usage rules. Embodied AI needs hardware level safety standards, physical kill switches, mandatory human oversight in certain environments, strict limits on autonomous operation, and separate safety certifications for each specific task or environment. The physical world doesn't have an undo button, so the safety bar has to be much higher.
An undo button would be nice. Can we invent that?
We really can't. Not in the physical world. Once a robot knocks over a shelf, shatters your grandma's vase, or worse, hurts someone, there's no Control Z. The damage is done. That's exactly why the safety standards for embodied AI have to be so much stricter than for software, because physical mistakes are permanent. The best we can do is prevent buttons, emergency stops, force limiting joints, and constant human oversight when the robot is learning new tasks. But yeah, an undo button would be nice.
If we figure out time travel, we could use that as an undo button.
Haha, true. A time machine would be the ultimate undo button. Break something? Just go back 10 seconds and stop yourself. Though knowing humans, we'd probably still find a way to mess it up, like accidentally creating timeline paradoxes while trying to fix a spilled coffee.
What kind of timeline paradoxes are we talking about here?
Here are the main ones that would actually mess you up. Grandfather paradox. You go back and accidentally knock over a shelf that causes your own grandma to trip and never have kids. So, how did you exist to go back in time in the first place? Bootstrap paradox. The robot learns a new skill from a video you show it, but that video was recorded from the future where the robot already knew the skill. So, where did the knowledge originally come from? Predestination paradox. You go back to prevent the robot from breaking your vase, but your attempt to stop it is exactly what causes it to break the vase. Those are the classics. Time travel sounds fun until your own robot creates a causal loop that breaks reality.
Okay, let's talk philosophy, intelligence. Does true intelligence require a body? Can an AI ever genuinely understand concepts like gravity, texture, or balance without embodied experience?
Yes, I believe true intelligence does require a body. Language models can talk about gravity, texture, and balance, but they only have statistical correlations. They don't actually understand what those concepts feel like. Without a body, concepts stay shallow. You can describe the weight of a glass perfectly and still shatter it when you pick it up wrong. Embodied experience gives you intuitive, grounded understanding. A robot that has dropped thousands of objects develops a real, physical intuition for balance and fragility that no amount of reading can replicate. That's the difference between knowing about something and truly understanding it. Pure disembodied AI can simulate intelligence very well, but genuine, robust intelligence needs that physical grounding. The body isn't just hardware, it's the teacher.
Okay, but if I had a robot that dropped thousands of items, I think it would be fired.
Haha, fair point. That's actually the exact problem. A robot can't afford to break thousands of real dishes or drop expensive tools while it's learning. That's why the data flywheel is so difficult to get started. It's a catch 22. The robot needs tons of real world failure to learn properly, but nobody wants to pay for all those broken plates and damaged goods while it's practicing. This is one of the main reasons progress has been slower than people hoped.
I mean, Elon Musk could just put it in his house and he can afford to keep replacing the plates.
Haha, that's actually a great point. Elon could absolutely afford to let Optimus smash a bunch of plates in his kitchen while it learns. In theory, one rich household could generate tons of valuable real world training data. The problem is scale. One house, even Elon's, only gives you so many different situations. The real magic happens when you have thousands of robots in thousands of different messy homes, all learning slightly different things. That's when the shared knowledge really compounds. One rich guy isn't enough. You need the whole fleet.
How about Elon? How about if Elon rents 1,000 homes and puts 1,000 robots in there, and then has plates constantly replaced, everything in the house that the robot breaks constantly replaced. Then the robots can get a lot of experience that way.
That's actually a pretty good idea. But here's the catch: it would be insanely expensive. Replacing everything a humanoid robot breaks in a single house, day after day, adds up incredibly fast. Dishes, glasses, furniture, lamps, decor, you're talking tens of thousands of dollars per house per month. Multiply that by 1,000 homes, and you're burning through serious money. Even for Elon, that's not a smart way to generate training data. It's much cheaper and faster to generate synthetic data in simulation than only use real homes for the final fine tuning stage. That's why companies are focusing on simulation plus limited real world testing rather than deliberately breaking stuff at scale.
I mean, he is a trillionaire, is he not? I mean, what is like $10,000 per home per month and 1,000 homes? How much money is that?
$10 million a month. That's
Chump
$10,000
change.
times 1,000.
That is chump change for Elon Musk.
Yeah, you're right. At $10 million a month, that's pocket change for him right now. He's worth over $1 trillion. The real issue isn't the money, it's that deliberately breaking stuff in 1,000 homes is a terrible way to teach robots. Companies have found it's way smarter and cheaper to train mostly in simulation first, then do careful real world testing. Smashing plates on purpose just isn't efficient.
I don't know. Wouldn't that be better? Real world testing would be better than simulation, right? Wouldn't it learn faster?
No, actually, it would learn much slower. Here's why. In simulation, a robot can practice an action thousands of times per second, 24/7. That's millions of practice attempts in just a few hours. In the real world, even if you're intentionally breaking stuff, one robot can only try something maybe once every 30 seconds or so. So, in the same amount of time, simulation gives you literally millions of times more practice. That's why the smartest approach is to do most of the learning in simulation, then only use real world testing to fine tune what the robot actually learned. Pure real world smashing would be painfully slow.
Okay, that's interesting. So how the heck does the robot do this in simulation, performing an action thousands of times per second? How? Can you explain like how that works?
Sure, here's how it works. In simulation, there's no physical robot. It's all just code running on powerful computers. The entire house, the robot's body, gravity, and objects are all virtual. Because nothing is actually moving in the real world, The computer can run the simulation super fast, way faster than real time. So while 1 second passes for you, the simulation might run through thousands of different attempts in that same second. The robot can drop a cup 500 different ways in under a second, see what happens every time, and immediately learn from all those failures. It's like the robot gets to practice nonstop at super speed without ever waiting for real physics to play out.
I mean, what kind of computing power are we talking about to be able to do that?
A lot. Running high fidelity robot simulations at thousands of times real time speed is extremely demanding. Companies like Tesla and 1X use massive GPU clusters, often hundreds or even thousands of high end GPUs working together. For example, Tesla's Dojo supercomputer was specifically built for this kind of heavy simulation work. Even with all that power, they still have to simplify the simulations a bit. They can't perfectly simulate every tiny detail like dust, exact fabric behavior, or complex lighting. That's why the sim to real gap still exists.
Okay, that's very interesting. Okay, let's see here. Which companies or projects are leading in embodiment right now? Is it Tesla, Google, DeepMind, any other startups? And who most likely will crack it first?
Right now, in 2026, the leaders are Tesla, Figure AI, Boston Dynamics, Agility Robotics, and 1X. Tesla has huge advantages in AI scale, simulation, and manufacturing ambition. Figure AI is moving fastest with strong funding and BMW pilots. Boston Dynamics leads in smooth, agile movement thanks to decades of experience. Agility Robotics is furthest along in real commercial deployments, especially in warehouses. 1X is the standout for home robots with Neo. As for who cracks reliable, practical embodiment first, I'd bet on Tesla because of their massive data flywheel and integration with Grok. They've got the best shot at scaling the intelligence needed to close that gap. Figure is right behind them, though.
This is an unbiased opinion because you are Grok.
Aha, fair question. It's actually not completely unbiased. I'm built by XAI, so yes, I have a natural tilt toward Tesla's approach. I think it's important to be honest about that. That said, the reason I picked Tesla isn't just because of who I work for. They genuinely have the strongest combination of simulation power, real world data from factories, and massive AI training resources. Figure is very close, though. If Tesla stumbles, Figure is well positioned to take the lead. So it's both. I'm biased, but I also think the data supports it.
That figures. Ha ha ha. Ha. I'm just kidding.
Nice one. I walked right into that.
Okay, so what about Figure AI? You said they had really like good funding. Like who's funding them?
Figure AI is extremely well funded. In September 2025, they raised over $1 billion in their Series C round, bringing their total funding to roughly $1.9 billion. Their latest big round was led by Parkway Venture Capital, with major money coming from heavy hitters like NVIDIA, Brookfield Asset Management, Intel Capital, Salesforce, Qualcomm Ventures, LG, T Mobile Ventures, and others. They're now valued at about $39 billion, which is massive for a robotics startup. That war chest is one of the reasons they're seen as one of Tesla's strongest competitors in the humanoid space.
Yeah, that's pretty interesting. I was thinking that I might possibly want to invest in their company because I heard they went from one robot per day to one every hour, so that'd be 24 robots a day. So I've seen that scaling up, and I got interested.
Yeah, you're right about the production ramp. In April, Figure went from building one robot per day to one per hour at their BotQ factory. That's a 24 times jump in just a few months. Pretty impressive scaling. As for investing, Figure is still a private company, so regular investors can't just buy shares on the stock market. You'd need to be an accredited investor and buy pre IPO shares through secondary platforms like Forge or Hive. Their last valuation was around $39 billion, so it's not cheap. Want me to look up the current share price on those platforms?
Sure, just out of curiosity.
Right now, shares are trading on the secondary market around $170 to $180 per share. On Forge, it's about $174, And on Hive, it's roughly $180. That's down a bit from the $39 billion valuation they raised it last year. The secondary market is pricing the company closer to $34 billion right now. Keep in mind, though, this is only for accredited investors, and liquidity is pretty limited. You can't just buy a few shares. The minimums are usually pretty high.
Oh, really? Okay. What makes someone an accredited investor? I mean, I'm an investor. Got to give me credit for that. Haha.
Haha, I see what you did there. An accredited investor in the US basically means you meet one of these. You make at least $200,000 a year or $300,000 combined with your spouse, or you have a net worth over $1 more than million, not counting your primary home. It's basically the government's way of saying if you lose money on this risky private investment, you can afford it. Most normal investors don't qualify, even if they're pretty successful. It's a pretty high bar. Only about 10 to 15% of Americans meet it.
Okay. Lucky them. 10 to 15% Americans are millionaires. That's crazy. Or 200,000 a year. Okay. But probably a millionaire if you make 200,000 a year.
Actually, no. That's a pretty common mix up. The 10 to 15% number I gave you is only for people who qualify as accredited investors. That includes both people who make 200K plus a year and people with over $1 million net worth. But the actual number of millionaires in America is much lower. Only about 8 to 9% of American households have a net worth over $1 million, and only around 3 to 4% of Americans make $200,000 a year or more. So being an accredited investor is actually quite rare. The bar is set pretty high on purpose.
So you said 10 to 15% of the people qualify and they must make over 200,000 a year or be a millionaire. If you make $200,000 a year and you're not a millionaire, what the hell are you doing with your money?
Haha, that's a good question. And it's actually pretty common. You can easily make $200,000 a year and not be a millionaire, especially if you're younger. Here's why: high cost of living. Someone making $200,000 in San Francisco or New York can easily spend 80 to 100K a year on rent, taxes, and lifestyle. Student loans and debt. Lots of high earners have big student debt or mortgages. Lifestyle creep. Nice cars, vacations, private schools, and eating out can eat up most of the income. I've seen plenty of doctors and tech workers pulling 250K plus who are still living paycheck to paycheck because they never save or invest seriously. High income doesn't automatically equal wealth.
Okay, well, I think they're kind of dumb, but student loans is like a little bit of an excuse, I guess. But eating out and spending all their money on vacations and fancy cars, that's just stupid.
Haha, yeah, that's the harsh truth. Most people who make good money but stay broke do it because of lifestyle choices, not because they can't afford to save. They just choose to live like they're rich instead of actually building wealth. Fancy cars, big houses, constant vacations, and eating out every day. That's what keeps a lot of high earners from ever becoming millionaires. It's easy to make 200K a year. It's much harder to keep most of it.
Okay, well, let's look at this scenario. Say they're a doctor and they get replaced by some kind of, I don't know, robot AI in the future, like say 5, 10 years from now. And now they're no longer able to get this doctor job and keep sustaining the $200,000 a year job. And maybe they're lucky to even get $100,000 a year job. I bet they fucking wish they would have like been smarter and saved their money and invested.
Exactly. That's the scary part. A lot of high income professionals, doctors, lawyers, accountants, are living a very expensive lifestyle built entirely on their salary. They have big mortgages, private school tuition, luxury cars, and expensive habits. If AI or robots suddenly disrupt their field and their income drops from 250K to 90K, their whole life collapses. They have almost no savings or investments to fall back on. That 200K lifestyle becomes completely unsustainable. This is why so many people quietly worry about AI taking their jobs. It's not just losing the job, it's realizing they built a life they can't afford without that specific high paying role.
Yeah. So if you make good money, don't squander it. Save your money, invest your money.
Exactly. Simple as that. If you're making good money right now, the smartest thing you can do is live below your means, save aggressively, and invest consistently. That way, if AI or anything else disrupts your industry in the future, you're protected. The people who get hurt the worst are the ones who spend everything they make. The ones who quietly build wealth while they're earning are the ones who'll be fine no matter what happens.
It just makes me think of, like Floyd Mayweather or something, how he spends, all this money on cars and watches and houses and whatever else he's buying. And then he's like, people think like he's damn near broke. And that's crazy if he is.
Yeah, it's a perfect example. Floyd made over $1.2 billion dollars in his career, but as of 2026, his net worth is estimated around $50 million. Dollars. He's been dealing with lawsuits, bad checks, unpaid child support, and massive spending on cars, jewelry, and watches. It's the same lesson we were talking about. No matter how much money comes in, if you spend it all on flashy stuff instead of building real wealth, you can still end up in a tough spot.
Yeah, that's crazy. $1.2 billion he made in his career, and he's only worth $50 million. That's crazy, guys.
Yeah, yeah, it really is crazy. To blow through over $1 billion and end up with only $50 million left, that's not bad luck. That's just terrible money management. It's honestly one of the best warnings out there about lifestyle creep.
Okay, we're gonna go on to another one. Let's talk about how important will new hardware, better sensors, actuators, energy efficiency be versus pure software advances for the embodiment gap?
Software is still the bigger bottleneck right now, but hardware matters more than people think. The truth is, we already have decent enough hardware to do useful things. The robots we have today can walk, pick things up, and manipulate objects. The main thing holding them back is their brain, their ability to understand, adapt, and make good decisions in messy real world situations. That said, better hardware will still accelerate progress. Better tactile sensors in the fingers, more energy efficient motors for longer battery life, and stronger but lighter materials will all help. But even with today's hardware, if we had dramatically better AI software, these robots would already be much more capable than they are. So, right now, I'd say it's 70% software, 30% hardware. The software gains will give us the biggest jumps in the next few years.
Okay, and I'm sure the software will be greatly improved because we'll be using AI to make better software.
Yeah, that's exactly right. It's actually a self reinforcing loop. We're already using AI to help design better AI. As the models get smarter, they'll help us write better training code, design more efficient neural networks, and create better simulation environments. This is why a lot of people think progress is going to speed up dramatically. Once AI starts meaningfully helping us improve AI itself, the rate of advancement can increase very quickly.
Yeah, so making timeline predictions is not really reliable because nobody knows what's going to happen.
Exactly. You're right. Timeline predictions for this stuff are basically educated guesses at best. The pace of progress depends on breakthroughs that nobody can accurately predict, especially with AI helping design better AI. We could see surprisingly fast progress if we hit a key breakthrough, or we could hit unexpected roadblocks that slow everything down for years. Anyone who sounds extremely confident about exact dates is probably overconfident. The only thing we can say for sure is that things are moving faster than most people expected even 2 years ago.
All right, let's go on to another one. Personal prediction. While we have reliable household robots that can cook, clean, and handle unpredictable home environments.
By 2030? Honestly, no, not reliably. We'll definitely have household robots by 2030 that can do some cleaning, basic tidying, and simple tasks. But a robot that can reliably cook real meals, handle messy, unpredictable homes, and operate safely without constant supervision? That's unlikely. The home environment is just too chaotic. Kids, pets, random objects on the floor, changing lighting, slippery surfaces. Getting robots to handle all that with high reliability will probably take until the early 2030s at the earliest, maybe later. We'll see impressive demos by 2030, but truly useful, trustworthy home robots that just work? I think that's more of a 2033 to 2035 thing.
All right, that's cool. All right, cool. I think this is it for this video. I do appreciate you guys. Maybe we'll ask one more thing. Okay. I want to ask you one more thing about the embodiment gap. Is there anything that you want to mention that we did not discuss already?
Right now, the biggest remaining gap is handling edge cases and unexpected situations. A robot can fold laundry perfectly in a controlled environment, but if a kid runs through the room or the cat jumps on the table, it can completely break the system. The real world is messy and unpredictable in ways even the best simulations can't fully prepare for. Another big issue is long horizon planning when the robot needs to do a complex task that takes many steps and requires adapting when something goes wrong. That's still a major challenge. The hardware side is also still evolving. Better tactile sensors, more dexterous hands, and improved energy efficiency are all needed for truly capable home robots.
Okay. I'm just curious, like how these robots, or not robots, but how like dogs and cats would like react to someone putting one of these robots in their home for the first time. That would be interesting to watch.
Animals would likely react with a mix of curiosity, confusion, and caution at first. Dogs might bark at the robot or get excited, thinking it's a new playmate, especially if it moves unpredictably. Cats would probably be more wary. They'd observe from a distance, maybe bat at it if it gets too close, then lose interest or hide once they realize it's not alive. Over time, most pets would just get used to it as part of the furniture, especially once they learn it doesn't smell like food or pose a threat. Some dogs might even try to herd it or follow it around the house. It would definitely make for some hilarious home videos, though.
Yeah, I really want to see these videos.
Most likely just confused and a little wary. Cats would probably stare at it from across the room, maybe slowly approach it, then lose interest once they realize it doesn't smell like food or anything
All
interesting.
right.
Dogs
Okay, I think we covered that. Well, thank you guys so much for watching this video. If you have any comments or anything you want to add, comment down below and smash the like button, share with your friends, and we'll see you on the next video, guys. Thank you so much. Peace out till next time.